Okay. So now we're moving to the next. Oh, how about it would really help if I shared my screen? So now we're in the second section, and we're looking at critical points in symmetry. Oh, geez. Okay. So critical point means extrema and intercepts. And extrema means maximums and minimums. Except we don't say maximums, we say maxima. We don't say minimums, we say minima. So let me write those words. So the plural of maximum and minimum are maxima and minima. And you can have a relative max or a relative min, or you can have a global max or global min. So let's look at an example. Say we have this function. Do you see a place that could be, would make sense to call it a relative max, a relative maximum?
That top bit where it's
This
flat.
here?
Yeah.
Yeah, I think so.
Okay, is there another place that looks like it could be in that area a maximum?
Maybe that part on the left.
The smaller side.
Good. So you can see that neither of these is actually a max of the function because the function goes to infinity. But sometimes the behavior of a function close in matters loads more than what it's doing at the extremes. So we've got a relative max. Say this is 1 and this is 5. This is 6 and this is -2. What would be the point for this first relative max?
That'd be
-2, 1.
Okay, good. And the second one?
6, 5.
Good. And likewise, we can have relative mins. So is there a place where we have a minimum kind of behavior, but it's not the minimum of the function?
The point closest to the y-axis.
Good. Let's call this 1/2 and this -2. And is there another one?
The one that's just on the line of x.
Yes. And let's call that one, let's see, 8. So what are the coordinates of the first relative min?
1/2 -2.
Good. And the second?
0, 8. Sorry, 8, 0.
That's all right. What is just to remember words that we've already talked about? What is the domain for this function? Is there any restriction?
No, so it'd be
Yeah.
-infinity.
All real numbers.
Infinity.
Yeah.
And what about the range?
All real numbers.
All real numbers.
Good. And how do you know?
The arrows at
Passes
the
the
end of the
vertical.
line.
Passes the vertical line test.
Yes, and we've got an arrow in the positive X direction going upward, and in the negative Y direction going to the right, I mean, to the left. We've got both directions, so everything is covered. We would say that this function has two relative maximums, two relative minimums, but no global maximum or global minimum. And that's because it goes to negative infinity and to positive infinity. But what about a function like this? Is that whole thing coming into view?
Yes.
Yes.
Does this have a global maximum?
Yes.
Does it have a global minimum?
No.
No.
Why is the first yes and the second no?
Because both of the arrows are pointing down, so there isn't like a higher in the infinity doesn't go higher in the X value.
That's right. That's right. So these relative minimums are not going to be a global minimum because we do go to negative infinity in both ways. But one of these relative maxes is going to be the global max. It'll be the highest value of the function. Okay.
I have a question.
Yeah.
So in that example, you had like 3 humps in the graph. What if like 2 or more were exactly the same y value? What would that be called, if anything?
So then say all 3 of these are the same y. So we would say that all 3 of them are the global max.
Okay.
So nobody wins over anybody else. So yeah, we would
I
just
have
have
a
3.
question.
Yeah.
You said by looking at it, could we tell what the domain was, and that it's all reals? What would it look like if it wasn't? Would that mean that it would have gaps or
So
pauses in it?
would be one. Gaps would be part. If this arrow went down, then there'd be a highest x, or pardon me, a highest y. We wouldn't go all the way to infinity in the y direction.
Oh, right. Okay. Okay.
So this is going up and to the right, down and to the left, covering everything.
Okay.
And no gaps in between. Okay. Intercepts are places where a graph crosses an axis. If it's a function, it can have many x-intercepts. It can cross the x-axis as many times as it may, but it can only have one y-intercept. And again, the plural of maximum is maxima, the plural of minimum is minima, and we say that the extrema are the maxima and minima. Did I define increasing and decreasing? Oh my gosh, I didn't. So increasing, I sure didn't. I really apologize. Increasing is if you're going from left to right, the function is going up. The graph is going up as you're going from left to right. If the function is going down as you go from left to right, that's decreasing. If the function stays the same as you go from left to right, that's constant. So let's write down. First, let's identify all of these points. What the X that I just put on the graph, what is that?
-3, 2.
And the place I just circled?
2, -1.
And this point at the end?
4, 3.
If it's filled in, if the dot is filled in, does that mean we do include it or that we don't include it? Which,
We do
in other
include.
words, yes, filled in means we do include, and we call these opens. Not filled in is like an open, and that's we don't include. So, do we have a relative maximum?
Yeah.
And what is
Yes.
its value?
-3, 2.
Good. And do we have a relative minimum?
-2. Oh, sorry, 2, -1.
Very good. So those ideas, those concepts are not really hard. None of them are hard. It's just that we have so many all at once. Okay, so let's also go ahead and label the intercepts. So here's one, and we're going to assume that every time it crosses in between two numbers, it's exactly halfway. So what would this one be?
-4.5.
Good.
0.
And let's see, here's the next one.
That's 0, 2.
And then we've got one here.
Half 0.
And here.
2.5, 0.
And 2.5, that's 5 halves. Okay, great. So it looks like we've labeled all of the intercepts and all of the extrema. Let's label all of the places where this thing is increasing. So let's see, I'm reading from left to right. Where is it going uphill? Where's the first uphill that I see?
-∞ to -3.
Okay, so I'm going to put increasing. We're not going to include infinity ever, but we will say that we go all the way to -3. So was there a question?
No, sorry.
That's cool. And let's keep looking. We're going to ignore this decreasing part right now. Is there another place where it increases, where it goes uphill?
Yeah, at 2.
From 2 to
4.
And it goes up until
4.
good. And we union them together. Union is like plus or the word or. So the interval from -∞ to -3 and from 2 to 4, this function is increasing. Is it decreasing anywhere?
From -3
From
to
3
-2.
to -2.
And anywhere else?
1 to 2.
And do I include that 1?
No.
That's right. And why do we include the 2?
Because it is part of the graph.
Yeah, it's a solid dot.
That's right. And do we have a constant area?
Yeah, from not including -2 to I think that's 1. I can't really see, but
Yeah, so -2 up to 1.
Yep.
Okay, beautiful. Here is yours. So again, you're looking for all of the extrema, which means maximums and minimums, all of the intercepts, and all of the intervals of increasing, decreasing, and constant. Let's see if I can fix this. Okay. Okay.
Yes.
Beautiful. Throw in the chat if you want. You can just send it directly to me or send it to the class. Whether or not this is totally review or golly, it's not hard, but I haven't seen this in a while. You know what I mean?
I'm only guessing that maximum is 2, yes?
There is no maximum.
well,
So
yeah,
there's a
there's no
relative max if you want to think of this whole y = 2 as a max, relative max. But yes, it's not going to be a global max. It looks like about half of you are saying it's 100% review, and half of you are saying that it's been a little while. Okay. Did y'all finish this? Okay. Symmetry. There are many, many facets of symmetry, but we're going to look at 3 of them. We're going to look at periodic, even symmetry, and odd symmetry. So periodic means that something repeats. That's pretty obvious. And this is thrown in here because when you do college algebra, you don't see any periodic functions because all periodic functions are trig. But are there periodic things that occur? In other words, is there a reason that we need functions that actually do repeat, repeat, repeat. What's something in the world, in nature, that is repeating?
Population rates, like birth rates.
Okay. Very good. Anything else?
Repeating. I'm gonna take a wild guess. Like manufacturing things. It's a repeat of manufacturing the same object. I guess.
Okay. What about things, natural phenomenon?
I mean, like the day and night cycle, the season cycle, all those repeat.
That's right. So those are the events that let us know that it's not a fluke. That repeating behavior is absolutely natural. So we say that a function is periodic if there exists a p such that f of x plus p is the same as f of x for some p. The smallest value of p is called the period. We say that a function is even if we plug in a negative x and we have the same thing as the regular function. And we say it's odd if we plug in a negative x and we get the negative of the original. So let's look at two examples of this. Let's see, let's let f of x be 1 over x. And to test for symmetry, I'm going to put a negative x in here. So let's see, f of negative x. What is that? How is that going to change the function?
Then it'd be
In
1 over
inverse.
negative x.
Good. And remember, with fractions, a negative in the denominator or the numerator is the same as the negative out front. So I can write that as negative 1 over x. And now I've got the 1 over x back. So this is negative f of x. So without even knowing anything about the reciprocal function, I can see that it has to be an odd function. So here's f of x. And sometimes they call odd symmetry twice folding symmetry, because if we fold along the y-axis and then again along the x-axis, what happens to the two parts of the graph?
They'll align.
Right. And twice folding is also called symmetry with respect to the origin. So odd functions are symmetric with respect to the origin. Let's look at an even function. Let's see. There's 5 minus x squared. And if we replace x with negative x, how do I write that on the right-hand side?
Be 5 plus x squared.
Well, we can't do two steps like that. So first we just replace x with negative x. Like that. And why can't we just skip that step? What happens now? What is negative x times negative x? Bless you.
Positive x.
Positive x squared. So this is equal to 5 minus x squared, which is, in fact, the original function. Let's see, minus x squared. So this looks like, there's 5. Looks like something like this. And even functions are symmetric with respect to the y-axis. So even functions are symmetric with respect to y-axis. There are two functions that it's good to have in your arsenal of functions that are just really, really well known. F of x equals x squared is a really nice even function, and f of x equals cube root of x is a really nice odd function. Also, g of x equals x cubed is a nice odd function. But what about square root? F of x equals the square root of x. Is that an even function?
I think it's an odd function.
Well, let's look at the graph. I'm going to change my share. Oh my gosh, it's over time. I'm going to go ahead and stop the recording.